Okay, so we are on to section 8.3, factors and greatest common factors. So we're going to start off with just a little quick review about what a prime number is. A prime number is a number that can only be divided by itself and 1. So for example, 3 can only be divided by itself and 1. Another good example is 7, 5, 11. A composite number is not a prime number. So a number that can be divided by more numbers than itself and 1, like 12, 28. Okay, any number that is not a prime number is known as a composite number. Prime factorization, we have done this before, but if I took a number such as 24, I would start by factoring it out, and when I factor, I do the factor tree. So I would take 8 and 3, 4 and 2, 2 and 2, and my prime factorization would be all of these prime numbers on the end of my tree. That would be my prime factorization of 24. And hopefully we know that GCF is the greatest common factor. So we'll start off. Example 1, I'd like you to try on your own. Classify if they're prime or composite. Remember, it's prime if it can only be divided by itself and 1. It's composite if it's not prime, or if it can be divided by more numbers than just itself and 1. Let's go ahead and do 90 together. So if we have 90 and we want to find the prime factorization of 90, we want to find all of the numbers on the ends of my tree and we want them to be prime. So we start with our tree. 9 and 10, 3 and 3, 5 and 2. Looks like it cannot go any further. All 4 of these numbers are prime. Therefore, the prime factorization of 90 is 3, 3, 5, and 2. Go ahead and flip the page. The next part is factoring each monomial. Also something that we have done before, but we will take a second to review it. So letter A, let's say we have 12a squared b cubed. The first thing we're going to do is factor out, by doing our factor tree, the number or the coefficient. 12, 6 and 2 go into 12, and for 6, 3 and 2. Then we decide, well, how can we write out a squared? And we see that we can write it out as a times a, and b cubed can be written out as b times b times b. Then, from here, we have our prime factorization of this monomial. 3, 2, 2, a, b, b, b. If I were to multiply each of these things together, I would end up back at this monomial. Okay, example 5, and this is really the heart of this lesson, is finding the greatest common factor. When you're looking for the greatest common factor, you're looking to see what is the greatest number and letter that both terms can be divided by. That is your ultimate goal here, is to look at the terms and decide what is the greatest number and or letter that both terms can be divided by. So we start with 15 and 16. And we see that 15 can be divided by 1, 3, 5, and 15. And then we look at 16 and we see that 16 can be divided by 1, 2, 4, 8, and 16. We notice that none of these are in common, therefore There is no GCF for between 15 and 16. But we can look at letter B. And we can start off with the coefficients and decide what is the greatest common factor between 36 and 54. My initial thought is, let's start with 6. Well, what is 36 divided by 6? I should get 6. And then 54. What is 54 divided by 6? And is that even possible? Divided by 6 would be 9. So now I'm left with a 6 and a 9. So clearly, 6 is not the greatest common factor between 54 and 36 because 6 and 9 are still divisible by something. They're divisible by 3. So then I take 6 and 3 and I say, well, I can divide each term then by 18. If I were to divide 36 by 18, I would get 2, and 54 divided by 18, and I would get 3. So therefore, 18 is the greatest common factor for the coefficients of 36 and 54. So we have 18. The next thing we want to find out when you're finding the GCF of two monomials is you have to decide how many of the variables do they have in common. For example, there's 2 x's here and there's 1 x here. So the greatest common factor between these two is that, okay, they have 1 x in common. Then for y, we have a y here and a y squared here. Well, this one only has 1, this one has 2, but they both at least have 1, so we can say that y is part of the greatest common factor. Now when we look at 54, we see that there's a z here, and then we see that there's no z over here. So you cannot say that z is the greatest common part of the greatest common factor of these two monomials. If we look at this, 18 is the coefficient, or is the greatest common factor for the coefficient. And then again, we decide how many x's do they have in common and how many y's do they have in common. And our greatest common factor would be 18xy. Looking at the letter C, 27 and 15. My initial reaction is to see if I can divide it by 3, if that will be enough. If I divide by 3, I get 9 and 5, and it looks like those cannot be broken down anymore, so it looks like 3 is going to be the greatest common factor for the coefficient of 27 and 15. Then we look at the a's. So we do one variable at a time. How many a's do these have in common? Well, they have 1 for here, 2 for here, so the greatest common is a, just a single one. And then there's 1b here and b squared here. Therefore, the greatest common is just going to be 1b. And over here we have 1c, but we do not have a c in this first monomial. Therefore, we cannot include it in our greatest common factor. Okay, we're going to go through one example of factoring out the greatest common factor, and then we will go through more when we meet in class. So I'm going to have you go ahead and skip example 1, A and B, and I want you to look at example 2. It says factor GCF. So we're factoring. When we factor something, we're basically making it simpler. We're pulling something out, doing something along those lines. When you factor out a GCF, the first step is to decide what is the GCF for all the terms. What is the GCF for all the terms? So looking at example 2, looking at 10, 15, and 5, negative 5, what do all three of these have in common? What is the greatest common factor between these three terms? I could take a 5 out of every single one of these and I would still have a whole number. So therefore, my greatest common factor is going to be 5. Then, I look and I see there are 3 A's for this term, 2 A's for this term, and 1 A for this term. Therefore, the greatest common factor between these 3 guys is going to be A. Then there's a B squared here, a B here, and a B cubed here. The least amount they have in common is just a single b. Once you find out what the GCF is, you're basically going to pull it out and then add parentheses. Okay, so you're going to pull the 5AB out from each term. So when I say pull the 5AB out, I would like to see 5AB parenthesis. Virtually what we're doing here is undistribution. We're undistributing. So once we pull it out in parentheses, we got to figure out what is left inside of here. And in order to figure out what is left inside of the parentheses, you need to divide each term by the GCF. So, for the first term, we see that it is 10a cubed b squared. If I divide that by the GCF, we know how to divide exponents. We know 10 over 5 is going to be 2. We know a cubed over a is going to be a squared, right? We subtract our exponents. We know b squared over b is just going to be b. We do the same thing with 15a squared b divided by 5ab. 15 over 5 is 3. A squared over a is a. And b over b just cancels out. Now for the last one, we have minus 5ab cubed divided by 5ab. My 5's cancel. My a's cancel. B to the third over b to the first is just b squared, but don't forget about this negative, so it's a negative b squared. If you wanted to check your answer, you would just have to redistribute and make sure that you ended up back here. So again, decide what the GCF is for all the terms, pull it out with the parentheses, and divide each term by the GCF to find out what goes left on the inside.